solve for x in the inequality e to the x minus 2 times e to the x plus 6 is less than or equal to 3e to the x. So we've got a factorized expression on the left hand side, and don't be sucked in by that and think you can use it in any way, because unless something factorized is less than or equal to 0 or equal to 0 or greater than 0, if you don't have 0 on the right hand side, then being factorized really isn't any use at all, because there's an infinite amount of things that could multiply together to make 3e to the x, or something less than 3 to the x. So we are going to have to expand, and we're looking to, hopefully we'll get some kind of inequality that we can factorize and use the null factor law. Right now we've got a bit of work to do first. So e to the x minus 2, e to the x plus 6, I'm going to move the 3e to the x, so minus 3e to the x is less than or equal to 0. We are going to have to expand this, so e to the x times e to the x. You could say that's e to the 2x, but looking at where this is going, I'm going to put e to the x squared. So e to the x squared, so that's those two times together, plus 6e to the x minus 2e to the x. Minus 2 times 6 is minus 12, minus 3e to the x, the 3e to the x that was already there, is less than or equal to 0. So now if we just group the like terms, 6, 4, 1, so that would be e to the x squared minus e to the x minus 12 is less than or equal to 0. And now we can look at this and potentially bring a dummy variable in. So I'm just going to bring this u in. You don't have to, if you're very confident, you don't need to do this, but I'm going to say let u equal e to the x. And the reason is because then we can get it into a very, very familiar looking quadratic inequality. So e to the x squared must be u squared, minus e to the x is just u, minus 12, so that's less than or equal to 0. So now this will factorize. Looks like 4 and 3, so need to have a difference of 1. Minus 4 plus 3, so u minus 4, u plus 3 is less than or equal to 0. So we're going to need a sign diagram for this thing. We're interested in sign diagram whether things are negative, 0 or positive. So we have these critical values, or zeros I suppose. Zeros when, so u minus 4 equals 0, so that would be e to the x minus 4 equals 0, or when e to the x plus 3 equals 0. So we need to check both of these for validity. So this one would be e to the x equals 4. Well, that's fine. E to the x can equal 4. Just think of, remember the graph of e to the x, it goes like this. It has a horizontal asymptote y equals 0. It goes up through 0, 1, and then it goes up to the moon. So somewhere, if e to the x equals 4, that's fine. It would be somewhere around here, no problem. For the second solution, oh, by the way, for this, that if we solve this, we would have to say we'll take logs of both sides, so ln of e to the x equals ln 4, so that would be x ln e equals ln 4. We should know by now that ln e is 1, because it's the power you raise e to in order to get 1, which e to the 1 is e. So x equals ln 4, and that is a 0. Okay, so for the other solution, this would mean if e to the x plus 3 equals 0, that would mean e to the x equals minus 3. Now that is a problem, because if you look at the graph of e to the x, you're never going to get a value of minus 3, which would be down here somewhere. So this is no solution. So we probably could do with a sign diagram. We know we have this 0 when x equals ln4, and we're interested in the signs either side. So I think the easiest way to do that would be if we consider this particular inequality here. So the u minus 4, u plus 3, and think about the signs of that. Remember, u is e to the x. So we've got e to the x minus 4 and e to the x plus 3. So if we just sort of think about those, either side of ln4, so if we kind of, and we have done this before, so it shouldn't be too bad. So if we consider the values of these either side of ln4, so we take the first vector, e to the x minus 4. Well, if you think about that, when x is ln4, so e to the ln4 will be 4, it's a power you raise e to get 4. So this would be 4 minus 4 equals 0. So if it is anything more, so if x is anything more than ln4, then e to the x is going to be greater than 4. So this here is going to be positive when x is greater than ln4, and it's going to be negative when x is less. Just think about it, it's the power you raise, ln4 is the power you raise e to get 4. So if anything else, just think, say x was ln5. ln5 must be a bigger number than ln4 because it's the power you raise e to get to 5. It must be bigger than the power you raise e to get to 4. So say x was ln5, then this number here would be 5 minus 4, and that would be positive. If x was, say, ln3 on this side, which must be a smaller number, this is going to be 3 minus 4, which is negative. If you look at the other factor, e to the x plus 3, well, e to the x, as we can see here, is always positive anyway, and plus 3 is always positive, so this is going to be positive in both places. So when we then times them together, e to the x minus 4 times e to the x plus 3, when we multiply them together, that must be negative times a positive is a negative there, and positive times a positive is a positive. So for this sign diagram, it is negative here and positive here, so either side of ln4. We are interested in when is it less than or equal to 0, so that happens when x is less than or equal to ln4. So the solution set, x is less than or equal to ln4.